Hello, my name is Cary Jensen, and welcome to CodeRage 7. This session is ClientDataSets Part 4, Aggregates and GroupState. I've given the previous parts at previous CodeRage and DataRage events sponsored by Embarcadero. So if you want to see those sections, please search the Embarcadero Developer Network and search for my name and the ClientDataSet presentations. But before we get to the topic of aggregates and group state, let's first do a brief overview of client datasets. A client dataset is a T dataset descendant. It is significantly different from other T datasets in that it holds all of its data in memory. And as a result, operations on that data, such as searching, sorting, inserting, editing, and so forth, is very, very fast because it's all in memory. Client datasets are also self-describing. They have metadata. So unlike a dynamic array or another data structure like that, there are actually types for each of the columns in the dataset. And they have not only a type, but they have a name. They are very flexible. They can be used in a lot of different situations. Most of us think of client datasets as being a layer of abstraction between your user interface and an underlying remote database server, but they can be used for a whole lot more than that. For instance, they could be used as a message in a service-oriented architecture type application. They could be used as a mechanism for transferring binary data, files, text files, binary files, and so forth from one location to another. They can be used to represent very complex relational structures through their support for nested data sets. Client data sets also have cache that can be managed. You can view records you've deleted. You can restore records that have been modified or deleted or inserted. You can examine a modified record and determine exactly which of the fields of that modified record have been modified. You can flush the cache and lose all your changes. You can go back to a specific change and undo that specific change, or you can undo the most recent change. There's quite a few things you can do with this. And then the final aspect of the client data set that makes it so interesting is that it is persistable. So you can persist that complex relational structure of data. You can persist the change cache, which means that you can come back to a client data set that you stored or persisted 4 or 5 days ago and examine those records that were deleted from it and restore them. You can take a client data set and you can store it into a blob field of a database and then retrieve it at a later time, and it is indistinguishable from the original version. So with that in mind, let's take a look at aggregates. Today I'm going to discuss aggregates and group state. I'm going to begin with a discussion of just what are aggregates. I'll talk about creating and configuring aggregates. We'll look at how to build aggregate expressions. I'll show you how to use aggregates, and I'll finish up with a discussion of group state and show you how group state can be used in your applications. Aggregates are unique to client datasets as opposed to other T datasets that you can find in Delphi and RAD Studio. An aggregate is an object that can automatically perform simple calculations on client dataset data. There are actually 2 types of aggregates available in the client dataset. One is the T-aggregate field, which is a T-field element that can perform aggregate calculations. The other is an aggregate, or a T-aggregate, and you can find it as a collection under the aggregates property of a client dataset. And these objects are distinct, and I'll make it clear how they are different from one another in just a moment. Aggregates can include operators and simple summary calculations, similar to aggregate calculations that you perform in the structured query language or SQL. The summary calculations you can perform with aggregates are count, min, max, average, and sum. The important thing about aggregates in the client data set is that these are operations that can be performed automatically, so that you do not have to write code that specifically execute these operations, or to write code to scan through your data and perform the aggregate calculations. Now, I mentioned that there are two types of aggregates. There's T-aggregate fields and T-aggregates. They are distinct from one another in that a T-aggregate field is a T-field like other types of fields in a client data set, such as calculated fields and data fields. And because it's a T field, you can bind T aggregate fields to data-aware controls. And you can also use them in association with visual live bindings. Aggregates, on the other hand, are objects that perform the calculations, but you specifically must read their values in order to read the value of aggregates. You cannot bind T aggregate to for instance, a DB edit. Aggregates can be a little frustrating when you are first working with them. The reason why is there are a number of specific steps that you have to take in order to get them to work, and a couple optional steps on top of that. Well, the obvious thing is you have to create the aggregate first. In the case of a T-aggregate field, you have to create a T-aggregate field. This can be done at design time, or it can be done programmatically. For a T-aggregate, you also have to create it, and that, again, can be done at design time or at runtime. The next thing you need to do is set the expression property to define the calculation that the aggregate will be performed. Now, I want to stress that you don't necessarily have to do all these steps in this order, but most of these steps are required, and if you leave one of these steps out, the aggregate does not appear to work. When I first began working with aggregates, I found them frustrating because it seemed like I felt like I was doing the same thing every time, but occasionally the aggregate would work and occasionally it wouldn't, and then I realized there were just that many steps and a couple of them cannot be avoided. So after you set the expression property, you'll also have to select the index to identify how the aggregate is going to be performed. Now, if you're performing an aggregate across all the records in your data set, an index is not required. For instance, let's say that you have 30 records and they all have a number that you want to summarize. You want to get the total, the sum of that particular number. In that case, you don't have to select an index name. But if you have your data grouped by some category, for instance, you have a table of orders and you want to calculate the total value of the orders, but organize them and group them by customer so that you get a total value of orders by customer, then you need to have an index. That index is going to have at a minimum at its first level the customer identifier, whether that be account number or customer name or some other element that you can use to identify how the grouping is going to occur. So the index and then the following, this next item, grouping level, together are used to define how the calculation is performed and over across which records that grouping is performed. Next thing you need to do is set the active property of the T-aggregate field or the aggregate to true. You also want to set the visible property of that object to true. And then the final step is to set the ClientDataSet's aggregate's active property to true. Now, there might be times when you want a particular aggregate not to be functioning and not to automatically perform its calculations. Well, you can control that by controlling the active property of the aggregate object. Similarly, there are operations you'll want to perform on the client dataset during which you do not want aggregate calculations to be being performed. For instance, if you have a client dataset and you've defined one or more aggregates and you're simply filling that client dataset with data programmatically, let's say you're reading from a file and you're inserting record by record data into the client datasets, you do not want that aggregate or any of the aggregates to be active. So at that case, what you would do is you would set the client dataset's aggregate's active property to false, and insert your records. And then once the data is filled and the client data set is set, at that point you would set aggregates active to true again, and the client data set will perform the aggregate calculations. If you left aggregates active set to true while you inserted records, the aggregate calculation would be performed upon every insert, and this would represent a tremendous amount of overhead and would decrease the performance of your insert operations. And so you need to take this kind of consideration into account when you're working with aggregates. You don't always want them to be active, and so these various properties are available to permit you to work with those aggregates. Let's now go over to Delphi, and I tell you what, I actually did not do this project, or I prepared this project, and I'm showing you it in Delphi XE, and the reason why is aggregates have been in ClientDataSets since ClientDataSets were introduced, which means that it has been possible to use aggregates for really quite a since Delphi 3. So if I was to use Delphi XE2 or Delphi XE3, Delphi would be injecting the unit name, the multi-level unit name structures into the uses clauses. And for those of you who are still working in Delphi XE or earlier versions even, you wouldn't be able to take this project and use it. So I have in fact specifically prepared this project so that you can use it in a whole wide range of versions of Delphi, even going back to Delphi 7 and earlier as well. Also, because Embarcadero has moved the various sample files around a little bit, what I've done is I've actually placed one of the sample files in the directory with this demonstration. So when you download the code sample, the file that I'm looking at that I'm using for demonstrating the aggregates is actually in this directory directly. So there's a little bit of code back here that also confirms or verifies that XML file is available. So now it doesn't. You're not limited to using aggregates only on client datasets loaded through XML files. Any client dataset data, whether you have created the client dataset at runtime and inserted data programmatically, or you're drawing data from a relational database through a dataset provider into the client dataset, you can use aggregates in any of those instances. In this one, I'm just happening to load the data from an XML file, and I'm going to perform the aggregate calculations here. Now, the aggregate's already here, and what I want to show you is the end result that we're going to get, but I am going to go back and then actually create that aggregate from scratch so that you can see how it is made in step by step. We also see another effect, and this is the latter topic I'm going to be discussing, which is group state. So you'll notice that customer number appears only on the first line for each customer, and actually you don't know that for certain, but if you look back at the actual data that is present here, you'll see that when the customer number changes, then in our sample file the customer number is presented the first time, and this greatly reduces the clutter we see. This is performed by using the group state that I'll be talking about later. Also, I have several types of aggregates. I'm using both aggregate fields, so this customer total field is a t-aggregate field, and therefore I can display it in data-aware controls and access it through DB bind scope and elements like that. I also have a couple aggregate t-aggregate objects, and these are accessed through these event handlers here, where I'm reading the t-aggregate object. We'll look at that code in a little bit, but I'll just click right now, and it shows that the average, customer average total is 8,575. So that is the average total there. So okay, let me close this and now discuss creating an aggregate field. Well, first of all, you see aggregate fields when you open up the fields editor. So I double-clicked on the client data set, and here's my fields editor, and you'll notice that down here at the bottom in this special location is a field all by itself, and those are the aggregates that we've defined. And what I'm going to do at this point is I'm actually going to delete this aggregate field, and that will remove it from the application. It's no longer here. And I'm going to go ahead and add the aggregate field. So how do we add an aggregate field? Well, in this case, I'm going to use the fields editor at design time. So I say I want to add a new field, and it asks me for the field name, and I'm going to call this one customer total. And of the type of field, well, actually here I'm going to come in and say this is an aggregate field, and it sets the type for me. And because this is a numeric field, there's no necessity for me to select the size. So I've checked that I want an aggregate field. And this is, by the way, the same approach you would take to, at design time, create a calculated field or an internal calc field or even a lookup field. Normally, when you are using the fields editor, you're creating simple data fields, and that means that the data that you are, the field you're creating is going to store data, and if you persist the client data set, that data will also be persisted. Aggregate fields are not persisted. So if you do a save to file or save to stream with a client data set with aggregate fields, there is no data that it's saving because these are live automatic calculations. So I'll go ahead and click OK to create my field, and there it appears down there in the fields editor. Now at this point I also have added a field to the actual structure of this client data set table. So if we come up here and poke around a little bit, we will see our T aggregate field right there. And now how do we, if we want to configure this at design time, again, we use the fields editor in order to select our aggregate field, and then use the object inspector to set its properties. So I mentioned a number of properties need to be set. The first property, now some of these properties were set for us. For instance, the field kind is FK aggregate, and the field name was set because we collected that information when we selected to create a new field. But going back to my slide here, the next step is to set the expression. Now let's talk about expressions a bit. Aggregate expressions involve almost always, I can't even imagine why you wouldn't have a field of the table in the aggregate expressions. I was about to say it always involves that, but you know, who knows, we might come up with some weird example where it's not the case. But in almost every case, you're performing some kind of operation on one or more fields. So in this line here, you see amount paid. Amount paid is actually a field it would be a field in the database, potentially. And in this case, we're using one of the summary operators, sum of amount paid. That is a typical summary operation. Now, what you can also do is you can perform these summary operations on two fields or more fields and use operators to create more complex expressions. It's also possible to perform summary operations on fields with constants. In fact, you can also define operations where you have two or more summary operations combined with operators. It is also possible to take the summary operation and combine it through an expression with literals. However, there are things you cannot do. You cannot perform a summary operation on a summary operation. It won't let you do that. And another thing you can't do is you can't take a summary operation and then perform an operation with a other field. Now, let me take a moment. This one is really important to understand because the summary operations are occurring across records. Okay, usually we're talking about one or more records that the summary operation is performed across. It doesn't make sense to say take these 5 records and summarize their price, get us a total of the price, and then multiply it by a field. Well, if it was 5 records that was required to summarize the price, which of the 5 records quantity are you going to use? I'm assuming here the quantity is a field in my database. So that's not a legal operation. You're not going to be able to perform that task. So let's go back over here, and what I'm going to do is create my expression to say that I want to have sum of amount paid, which is one of the fields in my database. Now, if I want to calculate the sum of amount paid across all the records in my table, then I don't need to define an index, and I don't need to select an index, and I don't need to select a grouping level. But if I do want to perform or grouping of my operations, I'm going to need to do that next step. Now actually, let me take you back for a moment here to the form to show you that this client data set has an index. Oops, I didn't mean to do that. I just needed to select this and bring up the object inspector, and you'll notice that if I go to index defs, I've defined an index. Now indexes belong to client data sets. They don't belong to the data in the client data set, so you're going to have to define this index yourself. You can either use index defs, which are referred to as persistent indexes, or you can use the index field names property to define a semicolon separated list of field names of the client data set, and that creates what's called a temporary index, but both indexes are valid for this purpose. In this case, I created an index def called custID, and it's based on the customer number field, so that I'm going to group over, that is, I'm going to summarize per customer number. So that now that I have that index selected, or I have an index created, I'm going to select my index name based on that selected or that defined index. So now I'm saying I want to group, I want the summary operation of amount paid performed by customer number. The next step is to define grouping level. Some indexes have more than one field. They're compound indexes. The grouping level identifies how many of the fields of the index to use to perform the operation. For instance, I could have an index that's sorted by customer number and then by month number, and I could, if I select a grouping level of 1, I'm saying I want to group over the first field of the index, customer number. If I want to get a summary by customer by month, then I would set grouping level to 2, which says use 2 fields of the multi-field index. In this case, I'm selecting it to 1. If I left grouping level at 0, I would actually not be using the index for grouping and would in fact summarize across all records in the client data set. My next step is to activate this aggregate. So I set active to true. I'm going to come down here and set visible to true. And then the final step is to set aggregates active to true on the client data set, but I have previously done that. So aggregates active is currently set to true right here. Now we previously had, let me go ahead and go back to my default layout. We previously had this field, the customer total, actually visible. Oh, there it is now. It's because I had left my columns defined. If the column hadn't been defined, after I created my aggregates active, in some cases you'd go over to the rightmost side and you'd see that that field would have been created for you. But a lot of times, actually I'd noticed in the last couple versions, actually the last like 7 versions of Delphi, that I actually had to not only, I actually had to come in and manually add a column and say that the field name for that column is customer total. And then once I set the customer total field, then over here we saw our customer total right there. And then I would take that customer total field and I'd move it to a position that made sense in the scheme of my application. And so right now, I'm showing the customer total field over here. And you'll notice it being totaled for customer 1221. That same value is repeated because it's the same value for every instance of that customer number. The next customer number goes to the next value, and so on and so forth. So that's how we create an aggregate field. T-aggregates are created using almost identical set of steps. The only difference is that we use this aggregate collection here. And I've already created a couple aggregates, T-aggregates. One's the customer average, and notice we still have expression, index name, grouping level, active, and visible for these fields. And so those are properties you're also going to set if you create an aggregate. And you create a new aggregate simply by clicking on the new button. And I'm not going to go through that steps because we just went through that. Those are aggregates, and you can see them functioning. So let's move on to GroupState. What is GroupState? GroupState is a property that identifies, well, it's not a property. That's not fair to say. GroupState is a concept that identifies the position of a record within its group. Grouping is this, the group here is the same kind of grouping that I was talking about with aggregates. Specifically, if I am grouping by customer number, then GroupState would identify a particular record with respect to a particular customer position. For instance, is this record the first record in this particular customer's group? Grouping is defined by the fields of the current index and the so you need an index in order to use GroupState. And if you have a multi-field index, then you are that GroupState could apply to different levels. Let's say you have 4 fields of a compound index or a multi-field index. You could identify GroupState based on the overall size of the data set, which is a group state of 0, or you could do it by group leveling of 1 or 2 or 3. And you determine group state by calling the getGroupState method of the ClientDataSet. getGroupState returns a set of tGroupPos_ind items. So tPos_group_inds is a set of tGroupPos_ind, and these include the flags GB first, GB middle, and GB last. What's important to notice is that this set could contain 0, 1, or 2 values. Actually, when I think about it, it's going to be 1 or 2 values. Either it's going to be the first, it's going to be somewhere in the middle, it's going to be last, or it could be first and last if there's only one element in the group. So let's look at how this is used in this particular example. So what I have done is, you may recall that we ran this and the customer number appeared only in one location and wasn't repeated. So how that is done is that I have attached an onGetText event handler to the customer number. So we're using the T fields on getText, and we're going to tell the ClientDataSet, well, actually we're going to say that if GB first is in the getGroupState set, then we set text, this value passed by reference, to equal to the value of the sender, which is a T field. Otherwise, we set it to blank. So if it's not the first record, we set it to blank. Now, what we may want to do is we may want to, well, let's leave it at that. That's perfect. I really like this. The first record of each customer has the customer record. Now, we may also want to do this with respect to that aggregate field that we created. So we'll go in, select customer number, go to its onGetText, and do something very similar. In fact, it's already here. If GB first in getGroupState 1, since our index has customer number as the first field of the index, we're grouping on 1. If it's it first, then we're going to and we're going to format that value out and assign it to text, otherwise we assign it blank. Now what I'm going to do here, this is actually, I like this approach quite a bit. I'm going to set this to GB last, and the difference here is that now this total will appear at the last record. So here's the first record, and in fact we can easily see this by moving it over here. First record for the customer. The last record shows the sum of all of the total amount. So if we wanted to actually bring amount paid over here, just slip it over right next to this. So here, this is the summary of all these values, and this here is the summary of all these values, and so forth. So that's GroupState, and that is T aggregates. You can find them in ClientDataSets. As far as the VCL is concerned, ClientDataSet is the only T dataset that has aggregates and GroupState. Well, thank you for spending time with me during this session. For the code samples and slides I presented here, please visit www.jensendatasystems.com/CodeRage7. There you'll find links for all of my talks here at CodeRage 7. I also want to invite you to visit DelphiDeveloperDays.com. This is a site where you'll learn more about the annual Spring Delphi Developer Days tour, 2 intense days of Delphi training with joint sessions. If you are interested in learning more about my latest book, Delphi in Depth ClientDataSets, you can find links for buying the book and some additional information like the table of contents and other information at jensendatasystems.com/cdsbook. Also, if you need to get in touch with me, if you have questions or want to follow up on something, please send email to cjensen@jensendatasystems.com. I do ask you to put an informative subject line, something like CodeRage 7 or Delphi or live bindings or ClientDataSets or something that'll catch my eye. This email address gets a lot of spam, so I look through it, and if you send me an email and you don't hear back for a number of days, go ahead and send me another one. I'm not avoiding you, I just may have missed it. But if you send something with a subject line that says hello or Viagra or something like that, I will not see that email. You can visit jensendatasystems.com to learn more about my company and our services. We do custom development, we do Delphi training, we also do consulting, and other services as well, including help systems and documentation. If you'd like to follow my blog, you can find that at caryjensen.blogspot.com, and my Twitter feed is found at twitter.com/Cary Jensen. Again, thank you very much for your time, and I look forward to the upcoming questions and answers.
Look at the queue. Here's a CDS question from Rick. When I was using an aggregate to generate an auto-inc value, in the after insert event on CDS, I would call autoinc.value is null. It would always be true. When I would inspect the value, it was greater than 1. I needed to switch to var is null autoinc.value. Do you know why that is the case?
Well, first of all, autoinc, this is not what aggregates are designed for, and the other thing is the value property of any field name. I'm assuming with that question that autoinc is the name of the field. Value is a variant, so that's probably why there is the problem. No, I'm not sure why that is, and I also think that it's probably an inappropriate use of the aggregate, because you're actually right in there in the churning of the client data set in its event handlers that are going on. You're trying to use a value that it's calculating. I would try to use a different mechanism.
And Roger made a note. First he was saying, hey, Cary, I wondered if you looked at QC 83435, where aggregates are incorrect when changing indexes. Then he goes, oh, slide 4 addresses the issue. Cool.
Yeah, I noticed that, and I actually believe that either Roger contacted me or someone else did and pointed out that particular quality control issue. So, well, I'm glad that slide 4 addressed it.
Excellent. Alf is asking, could aggregates be used to concatenate strings from several records, e.g. in my system? Go ahead. We
can stop right there. Can aggregates be used to concatenate strings from several records? No. There are 5 aggregate operators. They are count, and that's just the count, and then the rest of them are all associated with numerical values. Some min-max is not a numerical. That could be used on dates and things like that, but min, max, average, and sum. None of these are string related functions other than counting the number of records. That it cannot be used for string concatenation.
No, he could do a calculated field. He could create a field and write code that would concatenate things, right?
Well, you really have to you could do that, but the problem with the calculated field is calculated fields really produce calculations across a single record. Typically, that's what you use it for, rather than across records. And what it sounds like from his question is he wants to use strings in multiple records and use the aggregate to build a larger string out of the strings in multiple records. If the underlying database is a relational database, then this is something you need to do in your SQL. And it can easily be done using case statements or other operators like that. But this is not the purpose of an aggregate field.
Gotcha. Cary, do you know of a tool that let me add all my fields to CDS, then have a table created on the server with a call or code or menu option? I mean, you can save a CDS locally to either XML or CDS file. You'd have to write code, I guess, to call SQL create table and then iterate through the rows of and fields of a client data set, right? And formulate SQL insert statements or whatever.
Well, if you want a tool like that, I'll write you one in 15 minutes. It's very simple. Yep. So, yes, it's really. I've created quite a few tools that use the T-dataset interface to examine the metadata of a data set, and this isn't a client dataset issue at all. It's a general T-dataset issue, and then to do something with it, such as to extract the metadata from two different tables of the same name from two different databases and compare them and ask the question, has the structure changed? Creating a script in Delphi that examines the metadata and then generates a SQL create table statement is pretty straightforward. All you have to do is iterate through the T fields, select the field names, examine the field type. You may have to do a mapping to your particular relational database to map the T field field kind to the appropriate client, the appropriate field type of your database. But it's a very straightforward operation, and there's not something built in. It's something that you would write.
Yep. What are lookup fields used for?
Lookup fields are used to produce DB lookup fields, which can also be embedded kind of almost naturally within a DB grid. And it allows you to say that this field in this table must be restricted to the values of this particular field in another table. And it requires a little bit of configuration. There's 4 different parameters that need to be configured for that. But if you look at the lookup fields help in the help system, it should lay that out pretty simply. But a lookup field is used to restrict the values of a field in one table based on a link to another table.
Let's see, and Keith is mentioning in T-dataset you cannot look up a value with recno if you want to keep the current record position. Can this be done in CDS?
Okay, I love this question because it brings up a whole, actually it brings up the topic that I'm going to cover in ClientDataSets Part 5. You cannot look up a value with recno if you want to keep the current record position. Well, there's this concept in ClientDataSets called cloned cursors. Cloned cursors allow you to have 2 or more current records in a single data packet, or the OLE variant that is the records of a client data set. So when you clone a client data set onto the cursor of an existing client data set, you're actually creating a second client data set pointing to the same data that the original client data set is pointing to. And those 2 client data sets now are working with a common data store, and they can have independent current records, independent filters, independent indexes, independent ranges, and several other properties. In fact, I could have 100 different pointers into a common data set, and that's so clone cursors are the mechanism for doing that.
Gotcha. Okay. Oh, here's another long paragraph. Cary, I also noticed that when I do a post on a master CDS, the detail CDS will no longer be in edit mode. If I try anything, I get dataset not in edit mode error. Ancillary question to that is when I do a delete on the master, the detail records are not automatically deleted, and I get a cannot delete a master that has detail records. So this is all related to master detail client data sets with master source and field and.
Well, here's what you rather than having a
what's cascading deletes.
Now I'm assuming that the master and detail in this relationship are dynamically related client data sets through the master fields and master source properties, or a master client data set with a potentially a query as the detail table where it uses the data source properties and a parameterized query in the SQL part of the query. what you really want to do is create a master client data set with nested data sets. And the way you do this is you create the traditional dynamic master detail relationship with two data sets. They don't have to be client data sets. You point a data set provider to the master table of that relationship, and then a client data set to that data set provider. When you open that client data set that's pointing to the master table through the data set provider, an additional field will appear in that master data set for every child data set, and it appears as a T data set field. Now with that relationship, when you delete the master table, it will delete the detail records associated with that, or if you insert a master record and insert detail tables, it will perform that insertion as well. The important thing about this is that you performed all your operations on the master client data set. So through the data, pardon me, through the data set provider, which points to a data set that has presumably a connection of some part, when you call the post on the master, and actually apply updates on the master, it does both cascading inserts as well as cascading deletes. So it's the nested data sets that provide that intelligence in the relationships with the client data set. So it sounds like you're using client data sets, but not with the nested data set feature, and it's very intelligent about both inserts and deletes with master detail and even subdetail relationships. Each client data set can have up to 15 nested data sets, and each of those nested data sets can have up to 15 each nested data sets. You have to be careful, though, that the master client data set can get extremely large very quickly, depending on the number of nested data sets there are.
Yep. Is it possible to reclaim memory of deleted records of a client data set without close and reopen?
Well, this is an interesting question. When you call merge changelog or apply changes, the changelog itself should be flushed. I've assumed that reclaims memory that was occupied by the changelog or the change cache in the client data set. And at that point, then there's a lot of information about those changes, those deleted records, that is no longer required by the client data set. And both the data, which is the data is a property of the client data set and contains the current view of the client data set. Delta is the property of the client data set that holds that change cache. It is an OLE variant, and I'm assuming that the records of the OLE variant are released when they're no longer referenced after a call to merge changelog or apply changes or clear, cancel updates, which clears the changelog as well.
Yeah.
Now, I may be wrong about that. I haven't specifically tested this, but that makes sense to me.
Yeah. What was merge, changelog, and cancel?
Merge changelog,
yep.
Cancel updates, and apply updates.
And cancel updates, but not abort updates. Cancel updates.
Yeah, cancel updates.
Yep.
Apply updates.
I don't say the wrong thing, because I know a few things complete. Cancel updates and apply updates, but not abort, because abort means something's wrong, leave everything the way it is and figure it out and then restart again or do something, call customer service. No, delta is the variant. Yep. And the delta has the original value and the change value, right?
For updates, it has the modified record and the field by field. It has the unmodified record, all fields of the unmodified records, and then one value for each field in the modified record. The way you access that from your client data set is from a modified record. You read the old value and new value variant properties of the corresponding T fields of that record.
Yeah, and it needs to know that if you try to do apply updates, you could get if somebody else changed something back on, in some other application some way, you'd get this reconciliation error, right? Same
Well,
page.
what happens is that the dataset provider, now we're specifically talking about a situation where a client dataset is connected to an underlying database through a dataset provider. The dataset provider itself has an update mode property that defines what the where clause of the SQL statement that's generated by the internal SQL resolver is going to generate, and it gives you actually the option of having a testing whether the record as it appeared when you first read it actually exists or not before it tries to apply the update, or whether that record has at least the fields that you're trying to update are unchanged. So that allows actually a merge. There's also a setting that allows you to simply overwrite the record as long as you find it with the same key, which means the last person to post wins and their data is posted to the database.
Yeah, I think Mike is mentioning all of those methods do not release the memory.
Okay, I'm unfamiliar with that.
Well,
I have not tested that.
Okay. Cary, what exactly is the default expression for? It doesn't seem to ensure that the aggregate field contains a default value.
Well, the thing is an aggregate field is a T field. That means it descends from T field, therefore it has all the properties and methods of a T field, whether they participate in aggregates or not. So in this case, and this is very common in especially in the database side of Delphi, that there are properties that have no effect on a particular descendant of T field. Default expression doesn't play a role in aggregate fields.
Yep. Can I use aggregates with an ADO-based client dataset?
Well, client datasets are completely agnostic with relationship to the type of dataset from which they get their data. So absolutely, you can use aggregates with any dataset that the client dataset points to through a dataset provider, even third-party datasets, T datasets. So absolutely, you can use aggregates with the DBGO datasets that Delphi provides, or Borland Database Engine T-tables and T-queries, or the DB Express datasets. Absolutely.
Express or whatever. Yep. Or somebody else's system. I mean, you're right, CDS. Roger's saying, I don't see client dataset part 5 in the schedule for today or tomorrow. You were talking about sometime in the future, right?
Well, what I've been doing is I've been doing one specific focus of client datasets at each CodeRage and each DataRage, starting back, I think, at CodeRage 5. And I will, and so whether the next webinar or web-based Embarcadero event is a DataRage or a CodeRage, I will do client datasets part 5. If you want to get up to speed on client datasets, I ask you to go to www.jensendatasets.com/cdsbook, and you'll see links for buying my client dataset book. I have a link at the last slide there, and it goes into all the details I'm covering, but I'm just kind of feeding this out in a nice steady stream to create the body of information for the CodeRage and DataRage events.
From Keith about, is client dataset Windows specific?
It's basically runtime library specific, if you will, in the DB client unit. So any platform that supports the DB client unit supports client dataset.
You can use client datasets on Macintosh. You just have to deploy the Midas DLL library over to, or dylib over to the Mac, and that's a feature file, and it's easy to do under project deployment, and choose a feature file, click the Midas library, or you can just take the dylib from the redistributable area and copy it over to your user lib, so it's always over there on your deploy Macintoshes. But you use client dataset on Mac as well.
And what's really cool, and this is something that's not obvious, client dataset is more than just data. It's more than just a data abstraction layer for data in databases. It's a very, very powerful component for a lot of different operations. In fact, I had a half-day workshop here at the Entwinkler conference today, in which I spent the second half of the workshop describing a wide variety of ways in which client data sets are used, and it's not really data specific. These were using client data sets as a message in a service-oriented architecture type architecture, or as a background component that keeps track of the order of information that is used to drag and drop ordinal information into containers. You can use client data sets in far more applications than simply database applications.
Okay, let's see. What's the fastest way to search or filter a client data set?
The fastest way to search, the fastest way to search a client data set is to use find key. It uses an index, so it requires you to change an index. Now, here's an interesting point. This brings us back to a question that was asked earlier. Let's say I want to search a client data set and it's being displayed to the user in its particular order. What I can do is clone a cursor and then use find key on that cloned cursor. That has no effect on the current cursor position in the view that the end user sees, but allows me in the most efficient manner to go directly to the record that matches the search criteria. In terms of filtering, set range. Same idea. You need an index set. You have to use an active index. Set range is the absolute fastest way to filter a client data set. So let's take that a little bit further. The filter property is a little bit slower because it actually has to actively filter the records rather than use an index to select records based on the criteria. If you want to search or filter a very large client data set, and you want to do it absolutely as fast as possible, the thing to do is first do set range to restrict the records to the smallest subset that contains all the records you need, and none of the records, that contains all the records you want to search, and then you can apply a filter on top of that so that you're only filtering a subset of the records. So set range for filtering, set key for searching.
Roland was saying, but set range is not allowing like compares, or am I wrong? Is he talking? I wonder if
I don't see that.
Like?
Roland, okay, but set range is not allowing like compares, or I'm wrong. Yes, it does allow like compares. In like, we're talking about a partial match. However, the partial match can only occur on the final field of a multi-field set range, and it only occurs at only the end. So if you're searching for every customer names, if you're you've got an index on state and last name. Your set range, the first field of the set range must be New York, New York. Let's say if you're doing New York, and the last field of the set range can be SM star, and that will search for all customers in New York with the last name that begins with SM, assuming that your index is state and last name. So yes, there is partial. It's a partial match, and it's not exactly like a SQL-like, but it's a so that's my answer. You can do that like bit only on the last field of a multi-field index. So if you have an index with one field and you want to do a partial search, let's say your index is on last name, you can set a range on SM star, and that'll restrict the range to all customers whose last name begin with S and M, and then anything else.
Click here to download the files from Cary Jensen's live binding expression side effects. Click here to download the files from Cary Jensen's Client DataSets Part 4. Click here for more information. Click here for Delphi Developer Days 2013. Do you have the dates yet? Oh, no? Or you sign up to be notified about the dates and cities when you get there, right?
That's right. This is the time of year. I mean, this is the fifth year of Delphi Developer Days, and this is the time of year where Loy Anderson works with hotels and cities, and we also get feedback from our potential attendees as to where in the world they want to see us, and so this is where we start arranging our schedule, and we work with Embarcadero and other user groups around the world that have events to make sure that we are not conflicting with them, and so that we are providing an event that people can attend. We also always make sure that we're at locations that that people can easily come to. They can fly into a major airport and then get convenient ground transportation to the hotel. In some cases, for instance, Amsterdam, for the last number of years, I think it's the last 3, maybe 4 years, we've been literally 150 meters from the train station. So this is something that we always strive to do to make it very convenient for everyone involved. So we're very, very excited about this.
Hawaii, let's see, Barbados. No, anyway, kidding. All right, I got to get going, everyone. And again, thank you, Cary. Safe flight.
Thank you very much.